Okay, if you remember from that freezing point depression problem that you had seen in an earlier video, the problem uses a sample 1.61 moles of ethylene glycol and 0.500 kilogram of solvent. Okay, what you essentially had when you had that particular situation was a 3.22 molal solution, because that's what we calculated during the course of that particular thing. Okay, now remember, this particular substance was called ethylene glycol, and you should also remember when we talked about that, since it is a particle that will not dissociate or ionize, for every 1 mole of particles, okay, you get 1 mole of particles in the solution. All right, and also remember, we're talking about a colligative property here, and as we have said before, colligative properties are dependent only upon the number of particles, not the type. Okay, well, let's just say instead of having a solution like that, let's just say you have a 3.22 molal solution of sodium chloride. Okay, let's say it's a 3.22 molal solution of sodium chloride. Okay, if you have that 3.22 molal solution of sodium chloride, what you've got to remember, with this being in aqueous solution, that what will happen is you're going to have then 1 mole of sodium ions and then 1 mole of chloride ions produced for every 1 mole of sodium chloride. Okay, so in effect, you're going to have 2 moles of ions for every 1 mole of the sodium chloride particles. Okay, because it's going to be dissolved or dissociated in that solution. So why does that matter? Well, here's where that matters. When we look up here at this 3.22 molal, what we in effect have to do to calculate the correct freezing point depression is going to be this. We will have to take then our delta T sub F, okay, is going to be equal to that K sub F, which is that negative 1.86 degrees Celsius per molal, okay, times, all right, 2, which is going to be the number of moles that can be produced, okay, with every 1 mole of that solution, okay, times that molality. Okay, so you just have to know that that number that you take times the molality, the original molality, is going to be dependent upon the number of moles of particles that will be produced based upon the type of particle. So what you're going to end up having then after that, all right, is you're going to have a delta T sub F when you solve this is going to be negative 11.98 degrees Celsius. And if we're using sig figs with which what we should, it'd be a negative 11.99. Actually, it's going to be 12.0, negative 12.0 degrees Celsius. Okay, so it'll essentially be double that value right there. It'll essentially be double that value there, okay, based upon what you had to deal with over in here with that 2 based upon the number of moles. So don't make this difficult. Have a little fun with it. Ask questions if you have them. This is a really quick and dirty way to do this.